Welcome to lesson 3.5, which is all about transformations of the quadratic function. Hopefully, you watched my video on Desmos and you'll have a general idea of what the transformations do. So, here, when we're talking use transformations, we always like to have our our vertex form of the quadratic function. So y equals a times x minus h in brackets squared plus k. So a, h, and k each do something different. So a indicates a reflection across the x-axis if it's negative. So if it's negative, you'll see that it opens down and not up. That is what we mean by reflection across the x-axis. And if a is greater than 1 or less than -1, then it is going to perform a vertical stretch. If it's between -1 to +1, not including 0, then it's actually going to do a vertical compression. H just is going to move our parabola left or right, or a horizontal translation. And finally, K is going to indicate a vertical translation, moving our parabola up and down. And of course, remember the vertex of the parabola is at H and K. So if you saw the video in Desmos, you already have an idea of what that does. So let's explore this a little bit more. There's actually an order that we want to apply our transformations in. So when you use transformations to graph y equals a times x minus h squared plus k from our parent function of y equals x squared, we want to apply the transformations in this order. First, we want to deal with h. We want to know if it's going to translate left or right and apply that translation first. Once we've done that, we're going to look at what a is. We're not going to worry about the sign right now. And we're going to apply either the vertical stretch or compression if there is one. Remember, if a is negative, then we go to step 3, which is a reflection about the x-axis. So instead of opening up, our parabola is going to open down. And then finally, we're going to do the k part, which is the translation up or down. So, some things we know here about the vertex form. Well, given our equation y equals a times x minus h squared plus k, without even trying, we should be able to now tell the direction of the opening by looking at a. If it's positive, it opens up. Negative, it opens down. And of course, h and k are the coordinates of the vertex. And we can even go a little bit further. With a little bit of thought, we can determine the equation of the axis of symmetry. Remember, that's that vertical line that splits the parabola right in half. And that's going to be always at x equals our h from our vertex. So x equals h, that's our axis of symmetry. Well, if we think about it, we'll be able to figure the number of zeros or x-intercepts. Does it have 0, 1, or 2? We'll be able to find the y-intercepts simply by setting x equal to 0 and solving for y. And we'll be able to do a quick sketch of the graph. If we want to do even more work, we can rewrite the equation in standard form by expanding it and then simplifying the terms like we did in lesson 3.4. And then we can determine the zeros by either factoring or simply using the quadratic formula, but we're not going to get into that right now. So let's start off with an example here. And went a little too far. So we're going to sketch the new graph that results from applying these transformations to y equals x squared. So if you saw in the Decimals videos, that's what we start off with, y equals x squared, our standard quadratic relation. So we want to first translate 3 units to the right. Second, we're going to stretch vertically by a factor of 2. And third, we're going to translate up 1 unit. So I'm going to break it down here for you. One thing I always like to think of when I look at the vertex form, y equals a times x minus h squared plus k, is this part here, whatever is in the brackets, I like to call it opposite land. And why do I do that? Well, if we look at our equation and we have minus h, so say we have minus 3 in here, that's actually positive 3 when we're translating 3 units to the right. If it's positive 3, that means we're actually going 3 units to the left. So it's opposite of what we think. That's why I call it opposite land. Not quite as fun as Candyland, but we try. I know, bad jokes, bad jokes. All right, so let's start applying these transformations. Well, if we're going 3 units to the right, that tells us that h is going to be 3. We're moving 3 units to the right. H is 3. Well, we're stretching vertically by a factor of 2, which means A is going to be 2. That's our vertical stretch by a factor of 2. And we translate up 1 unit, so K is going to be positive 1. So now we can use all this information and we can figure out what our equation is. So we're going to have y equals, instead of a, we'll have 2. And then it's x minus our h value of 3 squared. And in this case, it's going to be plus 1 for k. So if you look just to the right here, our formula is y equals 2 times x minus 3 squared plus 1. 2 is our vertical stretch by a factor of 2. Even though it looks like it's minus 3, h is actually positive. That's opposite land. So that's our translation 3 units to the right. And k is positive 1. And that's our translation up 1 unit. We can do a little bit more here. We can look at an equation and we can list the transformations. So if we look here, we've got this wonderful formula, y equals negative 1/3 times x plus 4 squared minus 2. So you might want to pause the video and see if you can figure this one out first before going on. Remember, in brackets, opposite land. So that's my hint for you. H is actually going to be negative 4, not positive 4. All right. So if we think back to our steps, the first thing we want to do is we want to do our horizontal translation, which is H. H is negative 4. So what that means is we're actually going to translate 4 units to the left. So H is minus 4. I also kind of like to put in my what I know here, break it down. I know H is my horizontal translations, A is my vertical stretch or compression. If it's negative, it also has a reflection across the x axis. And K is our vertical translation. I'm just going to actually increase the size of those because I noticed that you couldn't see the negative in front of the 1/3 there. So, once again, h is negative 4. That means that we're going to start off with a translation 4 units to the left. So translate 4 units to the left. We have reflection across the x-axis. So that's going to make it um, open downwards. In this case, because A is between 0 and -1. We have a vertical compression by a factor of 1/3. We won't mention the negative sign here when we talk about the vertical compression or stretch, because we've already mentioned that with the reflection. And then finally, k is -2, which means that we're doing a translation down 2 units. So once again, negative in front of the A tells us we've got that reflection. 1/3 for A, which is smaller than 1. That tells us that we've got a vertical compression. If it was greater than 1, it would be a vertical stretch. H, we just have to remember opposite land here. So instead of +4, H is actually -4, which is our translation for to the left. And K is -2, which is our translation down 2 units. These seem difficult sometimes, but if you just break it down into the basic steps and work with them that way, I find that they're a lot easier to manage. As well, if you really get stuck, put the equation into Desmos and see what's actually happening. All right. Example 4. Determine the equation of the graph resulting from the following transformation of y equals x squared. So here, once again, it's going to give us what's happening in words. We're going to want to figure out what that equation is. So, translated 4 units to the right, well, that tells us that h is 4. We have a vertical stretch by a factor of 5. That's our a value. So a is 5. We're reflected in the x-axis, so that means our a is also negative. So it's 5 and becomes negative. So a is actually going to become -5. And then finally, we translate down 5 units, which means k is also -5. Whoops. Lost my negative. So, let's just get rid of that. That's something I was working on. Accidentally forgot to erase. Sorry about that. All right. So we translated 4 units to the right. Well, that tells us our H. We know A. So let's start there. We know A is vertically stretched by a factor of 5, and it's negative, so -5. Then we have our brackets X. H is positive. Remember, when we put it into the formula, it's opposite land, so we go x -4 squared. And k is translated down 5 units, so k must be -5. I hope that you understood that, and that you enjoyed that lesson. I know I like transformations. I know sometimes they can be a little bit tedious at the beginning, but the more you work with them, the easier they become. I strongly recommend watching the Desmos video that's right before this if you haven't already, and go into Desmos and just play around with the sliders to see what A, H, and K do. If you have any questions, as always, join me for live office hours or send me an email and I'll get back to you as soon as I can. Now you're ready to move on to Unit 3 assignment, so the end of unit assignment. Good luck on that. Let me know if you have any questions and have a great weekend. Take care.